Interval is over. Okay, as usual, all my tunes containing very basic knowledge. Okay, Lamai? It contain very basic knowledge you want right from the beginning, from like all the definitions and everything. After that, very few examples. Let me explain you the example because all the examples we have already done. So these examples I can just finish like very simple way. See, have a really good look at in the example number 1. It says like 100 Newton force is applied to move an object. Horizontal distance 5 meters is constant speed in neglecting the friction. So 100 Newton, and for 5 meters it is 500 Newton meters, that is 500 joule. In the same way, how much work to be done for when force of 5,000 Newton moves in a point application 0.5 meter in the direction of the force, any direction we don't know. You just need to multiply the force multiplied by the direction. It is 3,000 Newton meter. And this one here, calculate the work done by the objects along the inclined plane as given below. Force of 100 Newton multiplied by 7, that's the amount of meters, 700 joule. In the next part, the applied force is 100 Newton. The other force is like 50 Newton. Altogether, direction of the movement is like 100 minus 50, it is 50 Newton. So you have to find out the resultant force here. The resultant force is 50, you have to multiply it by 5 meters. Altogether, it's going to be 250 joule. So there are many more. So here you have to get the work done by just getting the cos component and sine component. Here only the cos component in the horizontal direction. There it with the real example. And the positive and negative work. Okay, it is also come up with like positive and negative. This part will entirely come in heat lesson. So we will quickly learn there is a thing called thermodynamics. In the thermodynamics, we have like this thing delta Q equals to delta U plus delta W. In that lesson, Hammo, I will have to struggle so much. Even 24 batch as a really good high brain capacity students. But if they have forgotten about this positive and negative type of work, then I'll have to teach this part again and go for there. So you just listen to this one very, very, very carefully because it is that important. Godak, what you know. So work either can be positive or negative depending on with the component of the force is same direction as the displacement. Okay, weight raise 100 Newton. Vertically it is 1.5. The weight was just vertically brought down in initial position. Work out the work done in the weight and bringing the weight down. So FD cos theta is mgh cos theta. In horizontally it is like see 150 joules for moving up. When the puts down, now it is like directly straight down, but because of the strain is his arms and he placed the weight down at angle of here 18 degree. Now you just read it like still the amount of work is 180, but the 150 it is a negative work. Earlier you just did it upward, now it is downward. So work also has a, even though energy is a scalar quantity, but positive and negative amount of works are there. If the work is done by the system, it is a negative. If the work done against the system, it is a positive. Okay. Now there are a few examples. So shall we try these examples or learn the next theory of kinetic energy? I think it's better for us to learn try the questions first. In the first and the displacement graph, here if you get force versus displacement graph, FD graph, what is the thing we find in FD graph, area under the FD graph? When you find in the area force into displacement, what is the force? Newton. This is meter. That means it is energy. Area under the FD graph gives you energy. Right. Shall we try these 4 questions? Very simple questions are there. I'd better maximally give you a time of 12 minutes to do this. You get like 3 minutes for one question. Your time allocation begins now. You push table through 3 meter with a force of 30 Newton. How much work you done on the table? Oh, it is 90 joule. Okay, understand? Number 2, in lifting a 20 kilogram bucket of water through 2 meters from a hole, work has been done, energy transformed. What work have you done? Okay, firstly, you have to find out the amount of energy transfer. After lifting it for almost like water bucket 2 meter, 20 times 10 times 2, 400 joules, or you can write like 400 Newton meter, whatever the unit, it doesn't matter. Now in the next one, how much work is done? When a force of 4000 Newton moves, it is point of application, um, 0.5 meter in the direction of the force. Right. Now the last one, find the work done against 100 kg water through vertical distance of 3 meter. Did you get this set of answers? I hope yes, because it is very simple. Rest of the questions are also the same. Right. Before going for power, we'd better go for new theory part that of wait. Kinetic energy. We have to go for kinetic energy theory. So open a very important theory note. Kinetic energy. Kinetic energy. Okay, kinetic energy. So write this in a new line with the definition. So give me a 1 minute. I'm back, Lamai. Kinetic energy. What is kinetic energy? Write the definition. The energy stored in moving objects due to motion. The energy stored in moving objects due to motion is known as kinetic energy. Okay. Right. We have to apply a certain force of F to do that. Accelerate an object from here to here under constant force of F. So as we know one thing, the work done is equals to what? Force into distance. Right. How to write the force here? How to write force? If we consider this one as the equation number 1, F is equals to ma according to Newton's first second law of motion. That is it. I can substitute it to here. 2 into equation number 1. You will get the result. Here it is as this is going to be K M A D. Mad. It is mad. Right. How to find out the displacement here? To find displacement, we have this scenario. U is there, V is there. These informations we get. And the acceleration of A is there. And the displacement is D. What is the equation that you can apply? Can you suggest an equation for do this? Suggest an equation to do this. UVA. D stands for S. Right. UVAS. What is it? You can apply V square equals to U square plus 2AS. Now the problem is if the initial velocity is equal to 0, you can cancel this off. A and A cancel off. You finally get an equation set for here of m v square. Haha, something you have already known since your level. Lamai. So sometimes we have to get kind of like keep in touch with people that we really don't know. That we really don't know. It is fine. It is like a casual meeting. So you just know him or her for some certain period of time. It doesn't matter. It's a casual meeting. But imagine if you have to work with him or her for a very long time. Sometimes we'll have to share some confidential details even. So don't you want to know more about him or her? Imagine like you are going to marry him or her. So how to know everything now? You have to check for the pedigree, isn't that? එයාලගේ පවුලේ අත ගිටා හොයා ගන්න ඕනේ කොහොමද මෙයා හැදිලා තියෙන්නේ කියලා. Now in the O level it's like just a casual meeting with someone. This is like a long term bond. In A level, deep root causes you have to know. That is why we need to do these derivations. But this derivation is no need in A level. No need. ඒත් දැනන් හිටියා කියලා කිසි වරදක් වෙන්නේ නැහැ. මොකද this is like not a official bond, not a marital bond, not something like that, but casual meeting. But still, it's better to know what is the pedigree. So it is something like that. So somehow these derivations are not like an enemy. We get a more chance to get used to the equation. ඒක නිසා හරි පොසිටිව් එක අරගෙන ටක් ගාලා ඩිරයිව් කරලා දාගන්න. Technically the derivation is no need. I think your time allocated is over. Shall we start the discussion? Hello. Shall we start the discussion? Right. Calculate the kinetic energy of a 45 gram golf ball traveling at 20 ms minus 1. Ek equals to half mv square equals to half times 45 into 10 to the power minus 3 because it's grams multiplied by 20. Again multiply by 20. It's 10 here now. Only minus 1 remaining. So 90 times minus 1 means 9 joule. I hope you got this answer. So in the next one, you can see now the speed got doubled. The speed got doubled. It is an MCQ technique. If the speed get doubled, you have to think some way. I will tell you what is the way. Firstly, I will do it in a regular standard method. Sorry, 45. Right.
it is going to be 90. This 0 is already gone. 90 times 4, 360 by 10 to the power minus 1. It is 36. Okay. Now, what is the ratio of 9 to 36? It's been multiplied by 4. If the velocity multiplied by 2, you can see that kinetic energy Ek will multiply by 4 times. If the velocity doubled, it getting 4 times. So here the velocity will be multiplied by 3 times from the initial. Let's find out how it is reacting. Okay. Okay. 3 times 6 is 18. 45 times 18. 900 minus, yeah, 450, 900. 900 minus 45 times 2 is like 90, 810. 81. So again, see the pattern at the beginning. 9, 36, 81. When the velocity get doubled, we get double. You can see now energy multiplied by 4. See, when the velocity multiplied by 3 got tripled, you can see kinetic energy multiplied by how many times? 9 times. 9 times 9 is 81. It got multiplied by 9 times because factor is v to the power 2. Can you understand the MCQ technique you find? If the velocity multiplied by 2, the energy factor should be multiplied by what? 4 times. If the velocity factor multiplied by 3, the energy factor should multiply by 9 times. Understand? I hope you understand that. Yes or no? Do you need more time to copy this, or shall I move to the next page? Next question. An object of mass 50 kilogram speeds up from 5 meters per second to 10 meters per second. What is the total kinetic energy before accelerating? Twenty-five by 5 is 125. 125 by 5 is 625 joule. What is the total kinetic energy after acceleration? Now see, velocity got doubled, energy got multiplied by 4. Understand? But for essay questions, you have to show in the proper way. But if it was an MCQ, you could easily multiply this answer by 4 and get this. Because 625 times 4 is 2500. How much work was done to increase the kinetic energy of the car? Because it is a certain object. Object එකක් ලෝක ආයෙක පොඩ්ඩක් ප්‍රශ්නේ තියෙනවා. Think it is like a kind of like a toy car. The work done equals to EK final minus E initial. 2500 minus 625, 1875 joule is the answer. Okay. Now in the third one, if you want to, you can write it. At the moment, when a shot putter releases 5 kilogram shot, the shot is 3 meters above the ground and traveling at 15 ms minus 1. It reaches a maximum height of 8 meters when the ground above the ground, when the falls to the ground, air resistance negligible. What was the potential energy of the shot when left the hand relative to the ground? It says like at the beginning of the shot, it is 3 meters above the ground. (150 joule). Next asking, what was the kinetic energy of the shot when it is left the hand? (15 by 15 is 225. 225 by 2250. It is like 1125. Am I correct or wrong? I think I'm correct. Or wrong? Oh no, I have to divide it again by 2, no? Again divide by 2 because this fact I forgot. It is like 500. Yeah. Is that the answer? Now in the next one, what is the total energy when the shot left the hand? You have to add the kinetic energy and potential energy together. Okay. What was the total energy of the shot when it reached to the maximum height? Okay. So you have to know one thing. So the total energy is the potential and inertial kinetic. This is going to be the same. There is a reason, but I have to show one thing here. Why? So the thing is, law of conservation of energy, we didn't do it. අටසිය දොළහයි නෝනේ is that 250 or 150? It is 150 now. No, it is 150. So we didn't do the law of conservation of energy. Total energy should be this thing itself. Potential energy is given here. What is the height? 8 meter. 400 joule. What is the kinetic energy at maximum height? To find this also we need law of conservation of energy. We have to leave it. Okay. What is the kinetic energy of the just stuck in the ground? Also we need the same thing. So the thing for us better to do these things in the next class after law of conservation of energy. Okay. So technically we have learned what is the thing we are just planned to learn for today. So typically our time is over for regular learning. So if you need any question to ask, you can ask because the regular class is over now. So you can leave if you want to, or if you have any problem related to last week, like students send me some questions and ask me how to do this, how to do that. So this is the time for us to do it. Ask me if you have any questions. We can discuss those. If you don't have, you can just leave because you can go and sleep. But if you have any kind of question to be asked, you can stay here and ask. So far nobody asked me anything. Good night, good night. Go. මම විනාඩියක් තව බලනවා කට්ටිය ප්‍රශ්න අහන්න නැත්නම් මාත් යනවා. The regular teaching time is over. Seem to be everybody don't want anything to know. So please go lah, guys, if you don't have any problem. Otherwise, we can just wind up the class. What is your suggestion? There are like 4 students remaining at the end. So if you have anything to ask, you can ask. Or let's just can just wind up the class. Okay. එහෙනම් ඉවර කරමු. මාත් එනම් මෙහෙම ලියුවෙන්න. Bye. God bless you ළමයි.